In a remarkable turn of events, the James Webb Space Telescope has made a discovery that is sending shockwaves through the scientific community. Just weeks ago, the telescope revealed the earliest known galaxy in the universe, but it has now detected something even more extraordinary: a supermassive black hole accelerating away from its host galaxy at an astonishing velocity of 4 million miles per hour. This latest find is of tremendous significance and has sparked a great deal of discussion among both astronomers and space enthusiasts. 32 seconds raising numerous questions about its implications for our broader understanding of the cosmos. The James Webb Space Telescope was launched with the primary goal of exploring the very first galaxies that emerged in the universe. In addition, it has captured breathtaking images of star and galaxy deaths dating back only a few 100 million years after the Big Bang. We invite you to join us as we delve deeper into the latest findings of this groundbreaking telescope. Be sure to like and subscribe for more content on these discoveries. 1 minute and 2 seconds. This new revelation challenges long-held scientific ideas regarding black holes. Traditionally, black holes are believed to be enormous gravitational entities that suck in everything around them, even light. However, the newly observed black hole seems to behave in an entirely opposite way. Instead of consuming light and matter, it appears to be generating new, young stars along a long stretch of space. This trail of newly formed stars has been spotted trailing behind the black hole, extending an astonishing 200,000 light-years away. Researchers are puzzled by this unusual behavior, as it diverges significantly from what we have observed in other black holes. A team of scientists, led by astrophysics professor Peter B., recently published their findings in the Astrophysical Journal Letters, with NASA's Hubble Space Telescope also confirming these observations. The data suggests that the black hole is stimulating new star formation as it interacts with surrounding gas, cooling it and allowing new stars to be born in its wake. 2 minutes and 6 seconds, but that is not the only exciting discovery NASA has recently made. The James Webb Space Telescope also captured an incredible galactic merger, one that provides an unparalleled view of the intricate dynamics between colliding galaxies. This merger, catalogued as ARP-220, is among the brightest and most intense galactic collisions ever observed. It shines particularly brightly in the infrared spectrum, making it an ideal target for Webb's infrared observations. ARP-220, located in the constellation Serpens about 250 million light-years away, is the brightest of the 3 closest galactic mergers to Earth. It is known for its ultraluminous infrared emissions, outshining even our Milky Way galaxy by a factor of 1 trillion. Approximately 700 million years ago, 2 spiral galaxies collided, triggering an intense burst of star formation. This created a compact, dense region that spans about 5,000 light-years and contains an extraordinary number of large star clusters, around 200 in total. Remarkably, this small region contains as much gas as the entire Milky Way galaxy. 3 minutes and 17 seconds. Previous radio telescope observations discovered roughly 100 remnants of supernovae scattered across less than 500 light-years. However, the latest findings from the James Webb Space Telescope show that the 2 parent galaxies are located 1,200 light-years apart. Each galaxy's core contains a rotating ring of star formation that emits significant infrared light, marking an exciting new chapter in our understanding of galactic collisions. Additionally, the most recent images from Webb show the striking effects of tidal forces between the colliding galaxies. The extended tidal tails visible in the images illustrate how the gravitational pull between the 2 galaxies has distorted their shapes. Furthermore, the reddish and orange streams represent scattered materials in the aftermath of the collision, giving scientists a better understanding of the violent processes at work during such galactic mergers. 4 minutes and 20 seconds. Another groundbreaking discovery from the James Webb Space Telescope came when researchers identified primordial galaxies located at the very edge of the observable universe. Initially, some skeptics questioned whether these galaxies were truly ancient or if they were just nearby galaxies that had been misidentified. To clarify, the data was shared with researchers across the globe, leading to the eventual confirmation that these galaxies are, in fact, among the oldest ever seen. The discovery is an incredible milestone for astronomy, as it allows us to observe galaxies that formed just a few 100 million years after the Big Bang. Scientists estimate that the light from these galaxies has traveled over 13.5 billion years to reach Earth, offering us a glimpse into the universe's distant past. The identification of these primordial galaxies sheds light on the rapid emergence of early galaxies and challenges our understanding of how quickly the first galaxies began to form after the Big Bang. 5 minutes and 20-second spectral data obtained by the James Webb Space Telescope confirmed that these galaxies lie at the very edge of the universe's observable limits, with some being so far away that even Hubble's capabilities could not reach them. This discovery is crucial, as it validates one of the primary objectives of the James Webb Space Telescope, to study the early universe by observing light that has traveled vast distances for more than 13.5 billion years. The ability of the James Webb Space Telescope to detect extreme redshifts allows it to peer into the infrared spectrum, providing an unprecedented view of the universe's earliest galaxies. This breakthrough has had a profound impact on our understanding of the universe's evolution and has given rise to new questions about the formation of galaxies in the early cosmos. 7 minutes and 19 seconds. According to renowned theoretical physicist Michio Kaku, the discovery of such ancient and massive galaxies raises questions about the creation of the universe itself. While these galaxies were once thought to be far less developed than the Milky Way, Webb's observations suggest that these early galaxies were far more mature than expected. In fact, some of these galaxies are up to 10 times larger than the Milky Way, challenging the prevailing understanding that it takes billions of years for a galaxy to grow to such a size. Kaku believes this discovery could be a game-changer, forcing scientists to rewrite their understanding of unexpected, massive structures that seem to predate what current models allow. Some astronomers speculate that these could be the remnants of primordial stars, the first generation of stars composed almost entirely of hydrogen and helium. These stars, known as population 3 stars, have never been observed directly, but their existence is crucial for explaining how heavier elements formed in the universe. If Webb has, in fact, found evidence of these stars, it would be one of the most important discoveries in modern astrophysics. Dr. Amelia Kessler, an astrophysicist at the European Space Agency, states, "We expected to find some of the earliest galaxies, but we never thought we'd be on the verge of detecting population 3 stars themselves. If confirmed, this could be the first direct observation of the very first light in the universe." 15 minutes and 30 seconds. A supermassive surprise. Meanwhile, another astonishing revelation has surfaced. Deep in the Abell 2744 galaxy cluster, JWST has identified a peculiar black hole, one that seems to have formed far too early. According to conventional theories, supermassive black holes take hundreds of millions, if not billions, of years to grow from smaller seed black holes. However, this newly detected black hole appears to have formed within the first 500 million years after the Big Bang, a time frame that should not be possible under current astrophysical models. This finding has left scientists questioning whether we truly understand how black holes form. One possibility is that these supermassive black holes were created in a completely different way than we previously believed, perhaps from the direct collapse of massive gas clouds, skipping the usual process of stellar death and accretion. Dr. Ethan Ramirez, a theoretical physicist, comments, "If these results hold up, we might be looking at an entirely new way for black holes to form, one that defies everything we thought we knew about their origins." 16 minutes and 45 seconds. A strange signal from deep space. As if these findings weren't enough, Webb has also picked up an unusual signal, one that appears to be coming from a location near a distant quasar. The signal, detected in the radio and infrared spectrum, exhibits a repeating pattern that scientists cannot yet explain. At first, astronomers believed it to be a pulsar or a fast radio burst, both of which are known to produce periodic emissions. However, this signal does not match the patterns of any known celestial object. Some researchers speculate that it could be a new type of astrophysical phenomenon, while others entertain more controversial possibilities, including the idea that it could be a sign of an advanced extraterrestrial civilization. While it's too early to draw conclusions, this is unlike anything we've seen before, says Dr. Helena Carter, a lead researcher on the project. We are actively working to rule out natural sources before considering more exotic explanations. 18 minutes, the next frontier. With each passing day, JWST continues to push the boundaries of human knowledge, revealing a universe that is far more complex than we ever imagined. Whether it's rewriting the history of galaxy formation, uncovering the origins of black holes, or detecting enigmatic signals from deep space, one thing is clear. We are standing on the precipice of a new era in astrophysics, one that may force us to rethink the very foundations of our understanding of the cosmos. As we look toward the future, scientists eagerly anticipate the next generation of space telescopes, such as NASA's proposed Habitable Worlds Observatory and the European Space Agency's LISA mission, which could help us unravel even deeper mysteries. But for now, the James Webb Space Telescope continues to astonish us. One discovery at a time, scientists sift through the vast amounts of data pouring in from the James Webb Space Telescope, JWST. One thing becomes increasingly clear: the early universe was far more dynamic and complex than anyone had predicted. With every new observation, Webb is uncovering anomalies that defy existing cosmological models, forcing astrophysicists to rethink long-held theories about the formation of galaxies, black holes, and even the fundamental laws governing spacetime itself. One of the most perplexing recent discoveries involves a series of enormous structures, possibly protogalaxies, that appear to have formed only a few 100 million years after the Big Bang. These structures, spanning hundreds of thousands of light-years, contain dense clusters of stars that should not have had enough time to form based on existing astrophysical models. Either the laws of physics work differently in the early universe, or we're missing a crucial piece of the puzzle, says Dr. Anika Rao, a leading cosmologist at Princeton University. This revelation has led some scientists to propose a radical new hypothesis, one suggesting that the early universe may have undergone a far more rapid phase of galaxy formation than previously believed. Could an unknown force or mechanism have accelerated the growth of these galaxies? 19 minutes and 10 seconds. The question of dark matter and dark energy. One possible explanation for the unusually fast formation of galaxies is tied to the mysterious nature of dark matter and dark energy, the invisible forces believed to shape the cosmos. Until now, dark matter has been understood as a form of invisible mass that helps galaxies hold together, while dark energy is thought to be responsible for the accelerated expansion of the universe. But JWST's latest observations challenge these notions. Some of the distant galaxies detected by Webb appear to be rotating far too fast given their estimated mass, suggesting that either dark matter behaves differently in the early universe or entirely new forces are at play. What we're seeing could indicate an early form of dark matter, one that interacts differently than the kind we observe today, says Dr. Youssef Karim, a theoretical physicist at MIT. Meanwhile, Webb's deep field images have provided more precise measurements of cosmic expansion, and some of these findings conflict with previous estimates of the Hubble constant, the rate at which the universe is expanding. If confirmed, this could mean that our current understanding of dark energy and the fate of the universe itself may need to be revised. 20 minutes. The enigma of the anomalous signal. Among the many discoveries made by JWST, one in particular has captured the attention of the world: a mysterious, repeating signal from the distant reaches of the cosmos. At first, astronomers believed the signal to be a natural phenomenon, possibly from a neutron star or magnetar, both of which can emit periodic bursts of radiation. However, further analysis has revealed a strange pattern in the signal, one that does not match any known natural source. The repeating structure of the signal suggests that it is highly organized, leading some researchers to consider the possibility that it could be artificial in origin. It's important to remain skeptical, but the consistency and precision of this signal are unlike anything we've observed before, says Dr. Eleanor Vasquez, a radio astronomer working with NASA's SETI program. Some speculate that the signal could be an intergalactic beacon, possibly from an advanced civilization. Others believe it may be evidence of an unknown astrophysical phenomenon, something beyond our current scientific understanding. 21 minutes. Preparing for the next breakthrough. As excitement builds over these discoveries, NASA, the European Space Agency, and international research teams are already working on plans for the next-generation telescopes that could further investigate these anomalies. Among them is the LUVOIR, Large Ultraviolet Optical and Infrared Surveyor, a proposed space observatory capable of detecting even fainter objects at the edge of the universe. In addition, efforts are being made to develop quantum-based observational techniques, which could allow future telescopes to probe the nature of dark matter, detect exotic particles, and even test the boundaries of Einstein's theory of relativity. Meanwhile, JWST continues its mission, unlocking secrets that may redefine our understanding of existence itself. With every new image and data set, we are reminded that the universe is still full of surprises, waiting to be discovered. What do you think? Could we be on the verge of the greatest breakthrough in the history of astrophysics? Stay tuned for more updates as the James Webb Space Telescope continues its journey to the edge of the cosmos.